And this is the evaluation setup, and these are all homemade units. Here we have a GPS disciplined 10 MHz low phase noise and oven controlled crystal oscillator. This is the GPS antenna input, and it has two outputs, one of them disciplining this 100 MHz low phase noise oscillator, which is the reference for the next unit, the 16 GHz local oscillator described in video 27. The other output is the reference for the spectrum analyzer. This amplifier was shown in video 28, and finally the down converter. The construction of this unit was shown in video 29. This is my spectrum analyzer, set 2.5 to 13 GHz, and I also have set the tracking generator as an independent source, 17.5 GHz minus 20 dBm. The generator goes to the RF input, and the spectrum analyzer input is connected to the down converter output. Here is the schematic of the down converter. This is the RF port, this is the LO port, and here is the output of the unit, 1 GHz to 12 GHz. The overall gain is nominally 0 dB in the middle of the band, but with this broad span of 11 GHz, the gain will certainly fluctuate a bit around 0 dB. This mixer is specified for frequencies from 10 to 40 GHz at the RF and LO ports, and is expected to degrade its response outside this range. The AVA 183P amplifiers are broadband, 0.5 GHz to 18 GHz, and have a nominal gain of about 8 dB, reason why two of them were used. By the way, there are just 4 5.6 nanohenry inductors in the supply path, and not 5, as I said in the first video. This is the range of interest at the RF port, and this is the LO injection. After mixed, this is what you have at the IF port. Notice that there's not such a thing as negative frequencies in the real world, but they certainly exist in mathematics and are a result of the multiplication in the frequency domain or the convolution of two functions representing the signals in the time domain. In real world, this range of frequencies will appear mirrored in the positive side of the frequency axis. Notice that there is no inversion. So when the frequency increases at the input, it will also increase at the mixer output. This chunk of the spectrum will be eliminated because the amplifiers won't respond anymore, and mainly because the spectrum analyzer at the output will be set to the range of frequencies from 1 to 12 GHz. And so, this is what is expected at the spectrum analyzer screen, as we will see now. The marker shows that the frequency of this spike here is 1.5 GHz. The result of the beating of 17.5 GHz with the 16 GHz local oscillator. This other spike here is an artifact produced by the generator. Remember that tracking generators normally don't have the quality of a specialized microwave generator. I will show you now why the source of this artifact, connecting the generator directly to the spectrum analyzer. Now let's increase the generator frequency by 0.5 GHz. And pick the marker. We see that the output also increased 0.5 gigahertz to 2 gigahertz, meaning that there was no inversion after the conversion. Now the artifact. The generator was set again to 17.5 gigahertz, and we can see that the spike frequency is 2.875 gigahertz. Now let's connect the generator directly to the spectrum analyzer and see what's happening. Now we see that besides 17.5 gigahertz, the generator has some spurs. These two spurs here are below the response of the mixer and will be heavily attenuated. And this other one here, 13.125 gigahertz, will beat with the local oscillator 16 gigahertz and appear as 2.875 gigahertz. But not everything is a bed of roses. There is an unwanted portion of the spectrum, the image of the range of frequencies of interest, that will also beat with the local oscillator and will be translated to two regions in the spectrum. This one will be eliminated due to the same reasons explained earlier, but this other one will be a real problem because it will be at the same spot of interest in the spectrum analyzer but inverted, and will be just noise nuisance. The solution will be to use a sharp front-end filter, a high-pass filter, to prevent the image to reach the mixer, like this one. And the nice thing is that this is a real filter manufactured by Knowles. It's not cheap, but I am confident it will do the work. Now I set the generator to 13.5 gigahertz. This is inside the image range, and we can see here that at the output of the down converter we have 1.5 gigahertz, which is the difference between the local oscillator and the 13.5 gigahertz of the generator. Now I will increase the frequency 0.5 gigahertz to 14 gigahertz, and you see that the frequency decreased 0.5 gigahertz. It's now 1 gigahertz, proving that the image appears at the output inverted.